Or the regression analysis issue. The regression analysis statistical method used with Reform A and the Uniform Required Railway costing system to identify the causal relationship between cost output. The analysis mathematical manipulates the equation and the value of the one specific expandable variable and is evaluated the function of the value of one or more of the explanatory independent output values. The selection of an equation with economic validity regression result was determined through the logical explanation of the causal relationships, 2, the relationship with significant measure of the accepted statistical test, and 3, the judgmental experience of the researcher. Regression analysis performed for the 3 steps. First, available data, normally total expense for the cost set category for each of the railroad, potential relevant outmeasure for each of the railroad, are assembled. Second, the relationship between the cost and category one or more outputs is postulated. Third, the relationship is tested and mathematically manipulating the postulated equation until the best fit between the data and the equation is achieved. The Railroad Accounting Principal Board reviewed the 3 issues relating to the use of statistical analysis of the government general purchasing costing system. Variable method, cost elasticity, percentage, variable cost of coefficients, national individual variability measures, equation specifications. Variability method. Controversy exists with the proper variability methods used and is present with 4 different variable methods having been proposed. Interstate Commerce Commission percent variable current interstate commerce methodology and rail form A. Interstate Commerce Commission proposed and percentage value. Proposed Interstate Commerce Commission method of the unified railway costs system. Direct coefficient application and cost efficiency elasticity. Interstate Commerce Commission currently percent variable. The percent variable method used the Interstate Commerce Commission currently. The request for funding the RFA cost commutes the average percentage change in the cost related with the average percentage change with the level of traffic, which average cost elasticity, and F an 8% change in the cost was related to a 10% change in the traffic. Cost would be 80% variable. The calculation is based on the cost elasticity of the average density. Interstate Commerce Commission proposed percentage value. The percent value method proposed by the Interstate Commerce for the Uniform Railway Cost System provides a variable portion of the regression of the equation for the cost of the value of the entire equation for the method used for the phase 2 of the Uniform Railway Costing System. Compute the variable portion of the accounting group of the measure for the percent of the annual total expense being acquired, which can vary of the account of the group of the railroad of the group of the railroad. Direct coefficient application of the general cost of the equation, for example, the y equals a plus bx. The b represents the variable uniform cost value output. The x the method of the b multiplies sum of the value of the output x involved with the movement of the direction to obtain the estimate of the total variable cost for the movement. Similarly, for the linear equation forms such as y equals a plus bx equals cx2. This method would be calculate the total variable cost of bx2 bx to the cx squared. This method divides the total variable cost units into the output and the average variable unit of the cost given out. Cost elasticity employed for the method of differential calculus to determine the percentage change of the total cost given the infinitesimal change in output. The linear case of the application cost and elasticity result of the value are similar to the Interstate Commerce Commission proposed percentage variable. However, the nonlinear equation forms cost of elasticity average percent variable methods arrive at different results. Analysts of alternative railroad accounting principle prefer the use of the controlling accounts of approach for the 2 reasons. First, casualty principle favors either the cost of electricity, cost efficiency method to estimate accurately how the cost of change with respect to change in output, although the either 2% variable approach is accepted for the use of linear regression equations, as both are produced the results similar to the cost elasticity method. Neither measure accurately how the change would respond to the output of the nonlinear equation. Second, the railroad accounting principle record of the cost-efficient method of the practical reason for the due the impact compatible with the railroad form A with the unified railway cost system. Cost of elasticity appears more appropriate than the average percent variable with the production economically represented with using the nonlinear model, but the cost elasticity method used the most many contemporary railroad costing equation using nonlinear equation forms such as Wood 1983 and Downwooding 1986. The average percent of the variable method can be applied with the quadratic equation. The disagreement consisting on how to apply it to expeditional experiment with the exponents represented with the elasticity measured with reference to an expect term. The analysis must be used greater and apply the artificial constraints such as unity with elastic levels of individual expense categories for the railroad industry as a whole, with experience to generally increase the production company's total output and elasticity probably within not greater unity. However, the certain costs may rise with a greater percentage rate within output. They have the elasticity greater than unity. For example, the fuel usage may have an elastic greater than unity with the increase of the output accomplished with the heavier trains, lower horsepower weight ratios requires the greater idle time fuel is used without generating ton miles. Historically, a range between 0 and 100% has been indicated by the Interstate Commerce Commission for all the percent of the variable. The range limitation indicates while the total output increase the change of the cost could not vary, but more the percentage change in the output, implying the cost of the elasticity of the variation is between 0 and 1. Conceptual that the upper boundary implied of the total variable cost is. And it has the basically your slope comp and your factoring of a binomial polynomial kind of thing going on. Right, the definition is no greater than the total cost of the boundary represents the fact that the historical base of the total variable constant cannot exceed the reported expenses. Differential cost efficient equipment, the most straightforward is implied with the reference of recreational analysis of determine variable cost. Thus, avoiding necessity apportionation total expense into the variable constant portion, thus eliminates the allocation process of phase 2 of the unified rail costing system, which includes expense not regressed in default percentage. However, the direct coefficient method is subject to more significant problems, and regression analysis not precisely specified usually requires significantly more data than the representative reported to the Interstate Commerce Commission. National individual variability measure. The theoretical cost derived by the individual railroad data must be economically accurate measure of the railroad cost in each individual Class 1 railroad. It has Interstate Commerce Committee approved the equation for the use of the own data, but the question of variability would be more straightforward with where award of the variable cost of the governor, given the movement, would be calculated with the individual railroad data. The regulatory jurisdiction is determined with the revenue variable. The cost ratio would also be quite straightforward. According to the casualty, the data integrity principles, sufficient data points must be included with the regressions analysis to statistical reliability. At present time, sufficient data point can be collected with practically only the pool data for all the railroads on a national basis. According to the practical principle, national pool data can be used even when using individual railroad data would be more accurately, but sufficient data are not otherwise variable. Insufficient individual railroad time series data accumulated with the future with such data should be used to calculate individual railroad regression equations. Well, the nation pool data can be estimated with either individual national cost elasticity rail form A using national cost of elasticity. Railroad Accounting Principle Board research indicated the cost of elasticity should be applied only on the individual basis using the individual railroad's annual operating statistics. The process involved determining the function of the form coefficient of the regression equation based on the national pool of data to derive the cost of the elasticity formula for the regression equation, and inserting the individual railroad value with the individual independent variables in the cost of elasticity formula. The use of an individual railroad variability may also pose the implementation of the problem for jurisdiction thresholds based on the revenue variable cost ratios. It may require the individual revenue the variable cost ratio. Therefore, threshold test to be used. The level of regulated traffic remains the same for each of the railroad as existed with the railroad form A. Opinions differ on whether the Congress intended to set a proportion of the traffic to be regulated with an individual carrier or aggregated basis of the railroad accounting principle board. It's unable to find conclusively support on either operation. The equation specification. The Railroad Accounting Board principle recommends the Interstate Commerce Commission conditionally analysis they incorporate specifically designated measure of the Interstate Commerce Commission should test the size and the density of independent variables as well as the test alternative the equation form of the measure of production economies. Traffic density. The treatment of size and density was most significant criticism of the unified railway cost system equations received in comments individual railroad data are presently adjusted. But Interstate Commerce Commission was the size of the deflator of the Interstate Commission with the bathtub of the incorporated destiny. Some of them have argued with the size of the adjustment reduced for the dispersion around the regression equation for the more manageable side, therefore maybe yield more statistically valid results. Some have argued that not all the data points should be of equal importance with the establishing relationship between costs and outputs. In other words, they believe they are large carriers and can have great importance to the derivation of the cost equation, but they can be small carriers. Others have argued, however, that each of the railroads observed data deserves the weighting of the regression analysis of each of the observation represents equally validated information for the production function for the regression based on the cost of the system with the theoretical justifiable. Certain statistical assumptions must be made in regression analysis when the assumption requires that in the case of the function whose values increase marked over the relevant range, the average of the difference between the data points of the regression line at each of the level output remains the same. Call homeless accuracy. Given the relationship between the railroad size and fixed cost, the fact the average difference between the data points of the regulation increase as the size and those focused to fixed and cost increase of the system. Increase the statistical assumption be satisfied incorporated with the size deflation, dividing the both expense of and the operating of the parameter data and the size variable. Numerous studies have been conducted regarding the effect of the economy size of the route mile of the track density net of the 10 miles per route mile on railroad costs, where the studies do not produce the consequences of result that suggest for the economy size, at least for the Classic 1 run, may be less significant than the economy of the traffic density, regardless of the relative importance size of the density. Virtually all the studies agree with both sides of the density should be tested with a significant regression analysis. However, the past study has disagreed with the appropriate output variables equation with the form of the relating side of the density difference of the cost and charge of the maze. More students and specification various costs with modules warranted to develop the most accurate with cost estimate of the particular practical limits. Failure to casual variable in the model leads specification bias. Specifically, it will lead directly based in unknown direction, estimated with all the regression coefficients, and when it turns to imply that the variability estimates will also be based on an unknown direction potential, and a continuing effort should be undertaken to examine the equation forms, which not only include the size and density, but much of the also conservative efforts of multiple output measures in the effort to avoid this type of bias. On the other hand, the inclusion of more casual variables model will not always yield improved regression result. For example, the avoiding the casual variable model degree reliability of individual coefficients may increase. Moreover, the simple regression form may be preferably to a more the complex one with slightly improve the goodness of the fit. While the economically, generally considered to be a more critical factor to determine variability, certain amount of the group's different views they expressed regarding how the density should be treated. The Interstate Commerce Commission, the Unified Railway cost system includes both size and density measured, with others have been stated. Even though the Uniform Railway cost system equation includes the size and density measure, the economy, the density are identified effectively. The Railroad Accounting Principal Board recommends additional research should be undertaken to incorporate the equation, which allows the economies to be designated with measure where the relevant. Accommodations with the errors of the economy, the size of them being confused by the economy, the density of the economy, the size would refer to the long-range average cost of the curve, which becomes the less steep of the size of the firm increase, but the larger the firm, the lower the incremental cost per unit of the output. Harris also states for the size of economies generally and not issue with the general costing system of the Class 1 railroad that such economies presently with the size of the deflator, the size of the critical determination, pricing investment policies, and whether they are economy, their density, the bulk relatives in the wood, determine the railway form aid methodology is weak indicator of the size of economy. They believe, however, the weak indicator is the inconsequential size density used in the salient Class 1 railroads costing characteristics. Specifically, they are concerned with what happens if the cost output increases when they hold the route system or the miles of the rail line constant. The small railroad with a high traffic density may very well have the lower increased incremental cost than large railroad with low density. Alright, well, economy density total cost increases with the increase of the traffic. Both the rate of the increase in the cost incremental margin cost will smaller the level of the traffic increase. The economic density should not be confused with the decreasing average cost caused by the simplified by spreading the fixed cost over the large base of the marginal incremental cost that do not charge with the traffic level charge and economical density that do not exist. As noted by the most studied of the railroad operation costs is strongly suggest the influence for the cost of the result and the economy destinies are greater than those that result of the economies of the size. Railroad with significant unusual capacity faced with the choice of either doubling the density in the current plant with doubling their plant size while maintaining the same density, while the former the choice to assume that the increase of the density does not exceed the available efficiency capability may yield diseconomies. Equation form, because the progression equation that represents the underlying economy relationship between the output and the proper equation form, the critical important is an example of the actual change of the function of the size, the density, in a nonlinear manner, but on the linear equation to use the regression analysis, the actual nonlinear cost will never be discovered. Colinear equations, equations of exponential coefficients of independent variables, and linear equations with specific size and density variables may allow with better recognition. Economy, the disk economy, the disk density size, and should be tested out with according to the same of the very limited relevant range of the equation, but the similar with linear in respect for the output term that may be generated if accorded to accurate estimates. Many critics have realized the uniform railroad costing system equation form of the implication of the railroad form A equation form. Some has criticalized the lack of the specification employed with the unified railway cost system. A regression formulation have been proposed. Alternative Daughtry and Turnquist have been proposed the other equations, while also proposing the other equations. Fredelander and Spatty has stressed the collection of additional data that improved the regression. Wooded and Betricum and Swanson have in 1980 have suggested that less information would be sufficient to fill the purpose for the general purpose of costing and to be used. The equation for the forms divided to the linear and planar but non-linear but linear forms may involve the coefficient of time of the output variable with the output variable raised to the first power of the y equals a plus bx plus c z. Planar or linear depending on whether there or not a z term exists. Non-linear forms can also to each in the terms of the sum of the functions more when output the variable is squared for root of the output variable, etc. So you have your exponential and the quadratic formula. The equation for itself must be helped to reflect the economies output. The collinear equation of the equation of the coefficient of independent variables may allow the recognition of the reduction in economies. These economies where similar linear equations do not. For example, the quadratic formula y equals a plus bx plus cx squared shall affect the scale within the cx squared term. The c is the negative value. Then the more output increases, the slower the rate of the increase of the total expense. And releasing the 1980 the railroad cost study of the 1982 published the equation of the form that chose the state the deductive the responsible reason the reasoning approaching was used the selecting the equation of the deductive reasoning was using the previous knowledge of the variable consistent with economic engineering of the operation relations where they arise related to industry. Linear equation of the current equation for each of the unified railway costing equation linear with respect to the output measurement. Interstate commerce can believe the relationship among the variables but the equation may be not strictly its linear form closely. Approximately true functional form of the Interstate Commerce Commission states because of the data reported from the carrier as a whole rather than individual cost centers, the significant relationship may be masked due to the data aggregation, the resulting significant bias of the data. This is while all the database using the cost center information might best with represented with the curved line regression equation based on the data of the railroads as a whole might be best represented with a straight line. Nonlinear equation. The section presented the information regarding the two of the more commonly used nonlinear equation forms, exponential and the quadratic. The exponential form equation is known as the logarithmic form, since for the exponential form reduces the logarithmic form using the standard rule for the logarithm and studies structured as follows: y equals am to the b to the xc. Total cost constant term size variable exponent was the size of the variable density the variable exponent of the density variable. Use the group of the recommended equation form statistic advantage reflecting economy scales of the exponent of less than one of the density variables cost increasing by less than output increase at other states with the exponential result of the bias equation. Since the uniform railway cost system equation relates to the cost of the density variable, the linear radiation cost to increase by the same amount of the given and to increase the input. Within the range of Class 1 railroads with are represented with the uniform railroad costing system regression analysis. A commentator proposed another innovation with independent variables using the uniform railway cost system for the gross ton miles, car miles, locomotive unit miles, etc. Output variables. The uniform railway cost uses miles as road side variable. The uniform railroad cost equations along with the affirmation density variables. The commentation states that the density of the variable is the product of the true density variable. It's another variable. Thus, the size variable the unified railway cost system designs the variable and highly correlated. The correlation may reduce the statistical significance of the coefficient of independent variables. The commentator proposed a solution divided by the uniform railway cost system, the density variable, and the size of the variable, which also incorporated in an example. The commentator would divide the gross ton miles of the road or arrive at the gross tons. Quadratic equation formula, the quadratic equation formula of a linear output variable, the same output variable rate with the second power, y equals a plus bx plus cx squared. Y is the total cost. A is the constant of the constant type side of the variable side of the power. X is the output variable, and B and C are the coefficients. As described above, the Cx term allows the existence effects of the scale inside of the density economies. For the example, C is negative as an output, increase the declines indicate the economies of scale. The C is a positive rate, increase the accelerated given simultaneously equals increases into, but indicating this economies for the scale. Alright, Chapter 18, Information Requirements.